Good morning. Today we're going to look at how to solve absolute value inequalities. Earlier, we learned to solve absolute value equations, and we looked at a couple different definitions of absolute value to solve those equations, so we're going to review those quickly right now. The first one is a geometry definition of absolute value, and that was simply a number's distance from zero. So if we wanted to find something like the absolute value of x equals 3, we could think, well, we want the distance of a number from 0 to be 3. Well, we know that 3 is 3 units from 0, and negative 3 is also 3 units from 0. So the answer would be 3 and negative 3. The second definition that we looked at both can be said in words, and it's an algebra definition, and it's the absolute value of a number is, and we have two options, is it's itself if the number is positive or 0. So the absolute value of a positive number or 0 is just that number. And the absolute value of a number is its opposite if the number is negative. So if you want to take the absolute value of negative 5, that's a negative number, so you want the opposite of that number, which is 5. That's the algebra definition written in words. We can also put it in symbols, and this is saying the absolute value of x is, and it's either x if x is greater than or equal to 0, and it's the opposite of x if x is less than 0, or if x is negative. We're going to start off with an example here. The absolute value of x is less than 3. Now first we'll think of this in terms of the geometric definition, and we'll have a number line here. And what we want is the absolute value of a number to be less than 3. So we want the distance from 3, or from 0, because it's the number's distance from 0, we want it to be less than 3. Well, what numbers on this number line are less than 3 units away from 0? Well, everything from 3 all the way to negative 3, all of those things in here have a distance that's less than 3 from 0. And we put open circles around the negative 3 and the 3 because those are not less than 3 from 0. They're a distance 3 from 0, but not less than 3. So that was the using the geometry definition of absolute value. Now we want to use the algebra definition. To use the algebra definition, we have the absolute value of x is less than 3. Well, we know, I've asked the question many times, is this positive or negative? And hopefully you remember that we don't know. So we say if x is positive, takes a long time to write. The absolute value of a number is itself if it's positive. So we just, the absolute value of x would then just be itself. We write that equation. If negative, the absolute value of a number is its opposite. So the opposite of x is less than 3. Now, the one over here is fine. We can just know x is less than 3. Over here, we see the opposite of x is less than 3. We'll get rid of that negative there. We can either multiply or divide by negative 1. And when we multiply or divide by negative 1, we should remember that we have to change the direction of the sign. So x is greater than negative 3. As we've solved compound inequalities, we usually have the word and or in between. Well, by looking at this geometry, when we solve using the geometry definition, we see that we shaded in between the two numbers. Hopefully you recognize that as a conjunction or using the word and. which we'll get to this later, but when we have a less than sign, we're going to use the word and. When we have a absolute value is greater than a number, in the next example, we would use the word or. So if we wanted to, we could graph this again, and we would get the exact same answer as we did up here. To write this in the correct form, since it's an and I know we haven't talked about this yet, but we could write -3 is the lower part of our answer. So we have -3, and we're looking at this one. Here it says x is greater than -3, but if we read backwards, we could think -3 is less than x. So less than x, and then x, we see x is less than 3. So we can put as less than 3. The way that we read this is we can say -3 is less than x, which is less than 3, or we can say x is between -3 and 3. Now we want to solve this one. Again, we can either use the geometry definition or the algebra definition. We're going to do both here. So using the geometry definition, we see here that a number's distance from 0 is greater than or equal to 7. So here 0, we want its distance to be greater than 7 or equal to 7. Well, what values on a number line are the distance greater than or equal to 7? Well, as we just think about that, we realize that 7 is greater than or equal to 7, so we can put a circle around 7 and fill it in, and everything larger than 7 is at a distance greater than 7. Also, we know that -7 is at a distance 7 from 0, and then everything less than 7 is also at a distance greater than 7 from 0. Now notice, looking at this one, the graphs go in opposite directions. This reminds us of our compound inequalities that used or. So when we use a greater than sign or greater than equal, we're going to be using the word or. Now solving using the algebra definition, we have the absolute value of x is greater than or equal to 7. Well, is this positive or negative? Say we don't know. So let's say x is positive. If x is positive, the absolute value of x is itself, so we can say x is greater than or equal to 7. What about if x is negative? If x is negative, then we want the opposite of x is greater than or equal to 7. We don't have to solve this equation or inequality because it's already solved. We multiply both sides of this one by -1. We multiplied by a negative, so we have to switch the direction of the sign. We get x is less than or equal to -7. And as I mentioned earlier, this is going to be an or because it's a greater than or equal to, which means it's called a disjunction. So our solution just can be written like this. Can't combine it like we could for the conjunctions. If you graph this as a compound inequality, it again would look like this one. All right, this next one is a little bit different. Lenny, this is for you. I'm going to try to talk a little more excited. I've been talking boring, so I'm not feeling well, but I should still be excited. So this one is a little bit different because it has something inside the absolute value. We can still use the idea of the geometry definition. You have to be careful, though, because you're taking the absolute value of this thing, so you want this whole thing's distance to be less than or equal to 10. So what we think, a nice easy way to think about it is we want whatever makes this, what's inside the absolute value 0, we want less than 10 from that. So less than 10 units from whatever makes this 0. So we think about that. What makes this 0 right here inside the absolute value? Well, hopefully we can figure that out pretty easily. -5 would make it 0. And so we want the distance from negative 5 to be less than 10 units. So what's negative or 10 units over this way? Well, that would be 5. Negative 5 is 10 units. We want it to be less than 10 units away, less than or equal to, color in the circle, and we highlight all the way up to the negative 5, and then on the left side, what's 10 units away from negative 5 as we go in the negative direction? Well, that would be negative 15. Negative 10, or negative 5 minus 10 brings us to negative 15. Negative 5 plus 10 brought us to 5. Again, we color in the circle because it's less than or equal to, and we shade this direction. So again, the way that we thought of that is the distance of what makes this 0 is less than or equal to 10. Less than or equal to 10 units away from what makes this 0. The algebra definition is what's going to end up being more helpful as these things get more complicated. So as we look at this algebraically, we have the absolute value of x plus 5 is less than or equal to 10. Is this positive or negative? Well, once again, we do not know. So if what's inside there is positive, then the absolute value of a positive number is just itself, so we can leave it as x plus 5 is less than or equal to 10. And what if what's inside the absolute value is negative? Well, the absolute value of a negative is its opposite. Be very careful. You want the opposite of this thing, so the opposite of x plus 5. Make sure you put it in parentheses because you want the opposite of the whole thing. So is less than or equal to 10. Solving, we have to solve each of these now. So on this side, subtract 5 from both sides. X is less than or equal to 5. Over here, distribute this negative. So this is negative x minus 5. A negative makes whatever is in here the opposite of what it is. So a negative x and a minus 5 is less than or equal to 10. We're going to add 5 to both sides to solve this. Negative x is less than or equal to 15. Multiply or divide both sides by negative 1. Multiply or divide by a negative, so we must change the direction of the sign. X is greater than or equal to negative 15. We had a less than sign here, so that means we use the word conjunction, which means we use the word and. When we use the word and, we can write it as one line inequality. We have our lowest number down here, negative 15 is less than x. That comes from here. If we read this backwards, negative 15 is less than or equal to x. Forgot that we're equal to. And x is less than or equal to 5. Got the same answer as we did using the graph up here. Our last example up here, I'm not even going to use the geometry definition. It gets a little complicated. With that, you actually end up having to factor out a negative 3 and then work through it that way. I can show you sometime if you would like me to, so we're just going to use the algebra definition. So we think, is this positive or negative? We don't know, so we have to choose. We have to think both ways. So we write if what's inside there is positive. The absolute value of a positive is itself. So negative 3x plus 6 is greater than 18. We're using a greater than symbol. Remember, if we use greater than, that goes with disjunction, which is or what else could happen? Well, what's inside the absolute value could be negative. So we say if it's negative, you take the opposite of it. So the opposite of negative 3x plus 6 is greater than 18. Kylie and others, if you looked in the book, when we solved equations, you made this side negative You have to be careful doing that. I don't do that because that will take care of itself if you set it up this way. But if you do want to do it that way, whenever you take the negative part, you have to switch this sign right away. We'll look at a table later that will show us that. But again, when you take the negative part, if you want to just automatically make this part negative, you must switch this inequality sign. So we'll go ahead and solve both of these. We're going to start by subtracting 6 from both sides here. So negative 3x is greater than 18 minus 6 is 12. We divide by negative 3. Alarm goes off because we divided by a negative, so we change the direction of the sign. So x is less than negative 4. We're going to solve over here, distribute this negative. We get 3x minus 6 is greater than 18. We're going to add 6 to both sides. And we have 3x is greater than 24. Dividing both sides by 3, we get x is greater than 8. And we have an or here, again, because it was greater than as opposed to less than. Here is how you could write it, just the answer. We could also graph it. So let's bring a number line out here. And it says x is less than negative 4. And the compounds I'm doing above here. Although I know since it is or, and it's this absolute value, I know I can just put it right on the graph. It's an open circle because there's no or equal to, and shade in this direction. Highlight your arrow, and it's greater than 8. Circle it, and shade in this direction. Now remember what these solutions means. This means if I choose any value less than negative 4, it will work in this equation to make this true. If I choose any value greater than 8, I can plug it in for x, and it will make the inequality true. You can find this table in your book. It sums up the comparison between a conjunction, which uses a less than sign, or less than or equal to, compared to disjunction, which uses a greater than sign. This is kind of the geometry definition. The distance will be less than c units from 0, c whatever this number ends up being, or this number, and this is more than c units from 0. So the graphs would end up looking like this, and we recognize this as using and, which tells us down here that if it's a less than sign, you will use the and. If it's a greater than sign or greater than or equal to, you'll use or, and get you values in between two things, or get you values on the left and right of two things. It does not include the middle. You can write your solution like this. When it's and, it's a conjunction, so you can write it as one line of inequality. You don't need the and in there if you write it this way. Here you can use or. And just a symbol, I don't know that I ever mentioned this before, but there's a symbol for conjunction. It's this kind of looks like an A without a line. And then disjunction for or is a V. So it's not a V, it just looks like a V. From this chart, I kind of narrowed it down. I deleted a couple of things, but this is what I was talking about before, especially with Kylie, because I know that you studied or read through this on your own in another lesson. And so you can actually set this up a little quicker if you kind of just memorize this process. The other way just takes you through the understanding more, and you don't need to memorize this. It's just more intuitive from the definition. But this way, if it's a less than sign, we know we use and. So we could, right off the bat, we could write our two equations using this idea. We could take the positive of this, 3x minus 10 is less than 9. It's almost like you're just dropping the inequality. It's a less than, so we use and. and then we can put 3x minus 10. We change the direction of the sign right away. We put greater than, and we change it to a -9. So that kind of compares to how the book did it earlier. And so you can automatically set it up this way, although I do prefer the other way because it doesn't require you to remember that you have to change this direction and make this a negative. So over here, this is a greater than. Actually, with this one, you could simplify inside the absolute value marks first because they're like grouping symbols. So we could write, we have 7x minus 6x is just x. X plus 9, absolute value of x plus 9 is greater than 8. So here, what we could do, according to this table, is we can write x plus 9 is greater than 8, kind of just like dropping the inequality, or the absolute value. We're going to use the word or because it's greater than, and then we write x plus 9, change the direction of the sign, make it a less than, and also change the 8 to a -8. Again, if you solve these things in the way I taught you before, this will just work out in the problem, and you don't have to worry about remembering this if you just remember the two definitions. If x is greater than, or what's inside the parentheses is positive, then this is positive. If what's in here is negative, then you would use the opposite of it, and then the signs and negatives will work out in the end. And I know you have this on your paper already, your assignment paper, but this is the homework assignment. Go back and rewind and go over any questions if you need to, and I'll take questions on this later. Start on that homework.